Josh emailed me that for sure it's Monday. Did you get that?
Yep.
Okay.
So no Saturday for me.
Yeah, that's okay. It's a bummer. Hey, Chase, do you think you can reach that clock and set it? I know that it doesn't really stay set, but so were any of you? Did any of you watch the speakers last night? Did anybody watch the speakers last night? No one watched the speakers that we had last night? Oh. Oh, okay. Yeah. It was really good. It was really, really good.
Was it recorded or?
I did record it. You want me to post a recording? It was outstanding. Yeah. I think it would be worth watching. Definitely. Yeah, I'll post the recording. All right, 6:10, let's get in there for 7, 8. Everyone get logged in. 9. All right, so this is on module 7, switching. When does switch learn about a MAC address?
When it's sent to that destination, or if it doesn't know it, it floods that.
Well, even before that. So say that again? Yeah, on the incoming frame, right, or the incoming port. So again, if I'm the switch, right, if I'm the switch and this is connected, these are all connected to the ports. If Gabby sends a message, right, so if her computer sends a message, it's going to come into the port, and that MAC address table is going to record her MAC address and whatever port it came in on. And then let's say that that frame, right, is destined for Daniel's computer. If it doesn't see the MAC address for Daniel, then it's going to do what, Matt?
It's going to flood the available ports.
All the active ports. Active ports. That's an important distinction, and they'll get you again on the CCNA for that. Because like, let's just say that this side of the room is connected to the switch and this one's connected to another one, right? What will happen is it'll flood out all the active ports. But see, there's no computers back there that are active. So even though there might be a cable plugged in, if they're powered down or if they're quiet, you know, they're in shutdown mode or sleep mode, the frame won't actually go to them because they're asleep. So it's only active ports. It's only active ports. That's an important distinction, okay? And then it's going to flood out all the ports. So if we're headed for Daniel, right, it's looking for Daniel. And it's going to flood out, so it's going to hit Lou's computer. So what's your computer going to do?
Read it, but then realize it's not for it and discard it.
Exactly. Ozzy, same thing, right? However, it's going to get to Daniel's computer, and Daniel, what will your computer do? Yeah. It'll respond. Yeah, it's going to respond. So now once your computer responds, it's going to come into the port, right? It'll record the port and Daniel's MAC address, and then it'll go as a unicast message directly back to Gabby's, right? So it's, if you can see, kind of picture it, it makes sense, right? That's the switch is creating like a legend, right? Kind of like a map legend of how to find things, okay? Did you miss it? Okay, like, because that's what we were just talking about, right? How does the switch build a MAC address table? Well, it looks at the incoming frame, right? And so it's looking at the source MAC address. Now, when it's trying to get to the destination, it looks at the destination port. Okay, but to build it, it's always looking at the incoming frame for the build. It doesn't build it as it's leaving, it builds it as it's coming in. Yeah, port numbers. The MAC address table records a MAC address and it's associated with the port number. Okay, it's associated with the incoming port number. What resolves IP addresses to MAC addresses? What resolves an IP address to a MAC address? Which one? Which one? ARP. I just can't hear you. Like please speak up. Please speak up. I wish you would listen to the. I want everyone to listen to the speakers from last night. That's one of the things they said is they're looking for people that speak up, right, and talk for themselves and have a good presence. So I think that's important. This is a good practice place here too to just get comfortable talking in front of people, talking to people, and speaking up. And for the most part, I won't be mad if you get the wrong answer, but you always have the right answer, I would say. So yeah, it's ARP, right? ARP, Address Resolution Protocol, ARP. The MAC address tables and ARP work together. They don't really know about each other. ARP and MAC, they don't know about each other, so they help each other without really knowing it. Okay, they help each other without knowing it. Five minutes. Can you change it?
Yes.
Yes. Yeah, you can change it. You can shorten it. You can lengthen it. An example of a time when you might want to shorten it is imagine, let's think about like a public network like Starbucks. Okay, so people come in with their phone. It might attach to the Starbucks network, right? And then they leave within 5 minutes. They leave within a couple minutes. So a Starbucks doesn't necessarily want their MAC address table filled up with, random MAC addresses that are, have already been gone for 2 minutes or 1 minute. They may shorten it down to 1 minute or 2 minutes. It'll keep it in there if the MAC address is still there. So if you're still there with your cell phone, it'll keep it in there. But if it isn't in there, it'll flush it out. So you don't need your MAC address table filled up with MAC addresses that actually aren't using or aren't on your network. It's unnecessary. Potentially could even create some vulnerabilities because if your MAC address table is full, you could ultimately create a denial of service. So they just want to get them out. Yeah, it's not going to send it out the port it came in on. And now since we've had a conversation, what other ports doesn't it flood out to? Which that? The inactive ones, right. It doesn't flood out the inactive ones. Exactly right. So store and forward and cut through. What's the difference? Somebody tell me what the difference between store and forward is and cut through.
Store and forward, it reads the entire packet or whatever, but the cut through it just does first 64 or something.
Depending upon which one it is. So, right, store and forward, it's going to read the whole frame. So it takes longer, right? It's increasing the quality, but it's decreasing the speed. And then cut through, it's faster. There's two types of cut through. Fragment free and fast forward switching. What's the difference?
Fast forward, it just immediately sends it until it reads the source destination, or the
This, okay, I was gonna say the source destination, is there such a thing? Once it reads the destination, and then fragment free? What's fragment free do? The first 64, why would it read the first 64? What's the value of that? Yeah, for collisions and error detection. So usually what statistics have found is that if there's going to be an error, it's usually within the first 64 bytes. And so if after it's read the first 64, it's not detected any errors, it's assumed that most likely that frame is without an error. So depending upon what your network need is, you'll decide which one of the methods is most effective and efficient for your network. Cut through. Lowest level of latency. Yeah, fast forward switching. Yeah, it just looks at the destination and it's like, all right, we're going to take a chance on this, right? That's where we're going. Let's head out. Oh, ouch. Okay, now this is an interesting question. It says if a destination port is busy due to congestion, what does a switch do with the frames? What's something that the switch can do as it relates to the topology? What's something the switch can do as it relates to the topology? Or the media, the topology and the media. What can a switch detect? It can. Yeah, it can. It can detect traffic on the media. It can detect the topology, and it can detect the type of media, right? If we think back to what the MAC sublayer does, okay, and it controls media access control. It controls placement of the frames onto the media, right? It controls placement of the frames onto the media. So if this is the source over here, and it's sending a frame out, okay, notice this says if a destination port is busy. So if this port is busy for whatever reason, right? And it can detect congestion. What does the switch do? And it's actually talking about the source switch, okay? So this switch will actually manage or media access control placements of the frame depending upon what's going on at the destination, okay? And so what it does is it buffers, okay? It's going to buffer the frames. It's going to buffer the traffic. There's two types of buffering. What are they? Yeah, so port-based buffering, which means this port actually has a little program inside of it called port-based buffering, where it can store some frames. It can store some frames. And what was the other one, Gabby? Shared. Shared means there's a little bit of there's like a bucket. There's like a shared bucket where all of the interfaces, all of the ports on here will just share this storage and put the frames in there temporarily until it sees that this traffic has cleared up. Now, if the traffic doesn't clear up, all those frames just get dumped. They all just get dumped, and it kind of has to start the process over again. Ouch. The ARP. ARP. What does a PC use to determine the destination MAC address of the PC it needs to communicate with? Typically, PCs on the same network, a local area network, they are often aware of the IP addresses on the network, but not always the MAC addresses. And so they send out an ARP request. Okay? How many of you have done a ping and you've noticed that the first ping has failed? Okay? So the reason is because that device, that host device, it knows the IP address that it's trying to go to because you actually typed in ping and whatever the IP address is. So it knows the destination IP address. But if we're on a LAN, how do LAN devices communicate? Do they communicate using IP addresses? No, what do they communicate with? MAC addresses. And so the ARP request will be sent out looking, saying like, hey, I want to communicate with Ozzy, however, I'm on the local area network. And so really what I need is the MAC address. And so the computer will receive the ARP request through the ping, and it will respond with the MAC address. Well, that very first request, it's using up one of the pings. And so it can't actually communicate yet. It's just, it needs information before it can actually have a successful communication. Now, this is where the ARP request helps the MAC table without even realizing it. Because when the ARP comes in, it's coming in on a frame. And so when does the MAC address table learn about a MAC address? When it comes in. It doesn't matter that it was an ARP request. It doesn't matter if it's a ping. It doesn't matter what kind of frame is coming in there or how the frame is getting there. It can fill up the MAC table. So that ARP request, again, is helping the MAC address table without meaning to help it. Same goes with the reply. When the ARP reply comes back in, that MAC address table is going to learn the MAC address on the way in. So that's why that very first ping will fail. Now, if you turn right around and you ping it again, you won't see a failure because now all the information has already been learned. The ARP information has been learned and the MAC table information has been learned. Yeah, so it resolves the IP address to the MAC address, right? It matches that up. And then it's going to keep a table. Just like the MAC address table, ARP is going to keep a table. ARP is going to keep a table. Remember, next week you're reading Module 9, not Module 8. We're skipping Module 8 till the following week, okay? Module 9. And if you remember, I said Module ARP lives kind of between the data link layer and the network layer, because what it's doing is it's matching up the IP address to the MAC address, right? So it's living kind of in between because IP is at what layer? Network layer, right? Layer 3. And MAC is at what layer? Data link layer, layer 2. Exactly right. So it's kind of living in between. Whereas if we think about the actual MAC address table, again, what does the MAC address table keep track of? Ports, which live at what layer? Well, not port numbers as in the transport layer. We're talking about interfaces, like ports as in interfaces, F01, F02, F03 on the switch. So where do those live? Well, they're living on the switch, so they're kind of living between the physical layer and layer 2, right? Because they're on the switch, which functions at layer 2, and we would consider an interface, the actual physical piece of it, layer 1, right? So the MAC address table is going to map a port number to a MAC address. So that's again, because we're helping that frame move, right? We're helping the frame move because the frame inside of it is the payload. And what's inside the payload is the packet, right? So it's moving. So again, if you could think of it as we're creating like a map so that the data, overall the payload can start to move, okay? Yeah, where does it go? The default gateway. Exactly right, the default gateway. Let's see, Daniel, Joey, and Gabby. Good job. Nicely done. Okay, I've got that published. Go ahead and go mark it. Did everybody find it and get it marked? All right. Did we do flashcards? Did we team up for flashcards on Module 7? I don't remember doing that. Okay. Can you raise your hand if you have your flashcards? Okay. Joey, flashcards. And there's flashcards back here. Anybody missing flashcards? Yeah, we have like a bunch of flashcards back here. I don't know whose these are. I know it doesn't, Caesar? I think oh, maybe not. No, this is Caesar C. I have no idea whose these are. Okay, so Gabby, do you have flashcards? Matt, do you have flashcards? Caesar, do you have flashcards? Orgel, flashcards? Daniel? Marcus? No. Joey? Maybe. Ozzy? And Lou? Yes, okay. Where's Brody? Okay, Matt and Caesar, Lou and Gabby, Ozzy and Daniel, and then Orgel and Joey, and Marcus. Why don't you join in with Ozzy and Daniel? Okay, so go ahead and get together. Let's do some flashcards.
Come over here to the dead side, buddy. Only 2 remaining souls over here, those weeks.
I don't know what's happening.
Yeah, dude, no, it's all Gabby, not me, bro. She carries the side.
What's that? Daniel, Ozzy, and Marcus. Matt, you're with Caesar.
Oh, this was Caesar. I'm sorry.
Okay, Matt and Caesar.
Yeah. Oh, okay.
Okay.
I think there's a... That's why I was confused. That's why I was like, what are you talking about?
Matt and Caesar, Lou and Gabby, Marcus, Ozzy, and Daniel, Orgel, and Joey. You don't have cards. Okay, so then, hold up. Okay, so I'm going to put, okay, what am I doing? Okay, so Joey, I'm going to put you with Matt and Caesar, and then Orgel join Lou and Gabby. So we have groups of 3 mostly. Marcus, Ozzy, and Daniel. I have no idea. I mean, I'm thinking they might be Leslie's class. Huh?
That sounds like something she would do. Just leave them there to grade.
Well, no, I think Pam put them up there. Pam said she found them. I think she put them there. I don't know, but I want them gone. I'm going to send Leslie a message. Leslie, flashcards. I'm going to see if they're hers. Hi, Leslie. There are a bunch. Can you look and see if any of them are students from in here? I didn't notice any.
There you go. The data weekend.
Anybody look familiar?
Mario's in Jagdeep.
Okay, so that's my 150 students. Give those to me.
I thought it meant like the physical. What are the categories?
That must have been from last semester, since that's module 11.
I just wrote down like.
This is
Oh, we just finished module 11.
Oh,
Loop back address, Iana. Oh, but
basic
you're
router
right.
commands.
Yeah, these are. Link local. Yeah, you're right. These are from 140. Class B,
You can go ahead, go in.
Jagdeep, the transport layer, application layer. These are all Jagdeeps.
Yeah.
Okay.
This is the Mario's one.
And same thing?
Module 10 basic router commands.
Oh, yeah. Okay. Mario's was my student, but Jagdeep was hers. So I'm going to put them in here because this is where I usually think to look. And maybe those are old. Maybe they're all old.
Probably.
You know,
Where were they?
I have no idea. They weren't in here. I mean, Pam just put them all back there, and I asked her what they are, and she says they're flashcards that need to get handed back. She, you know, I'm not even sure she knew. Weird.
That's why you were saying to delay the subway. That's pretty much why.
Okay, so minimum. I know the maximum is 15, 18. You have a guess on the minimum? You got one, or what are the?
Oh, I was just getting ready to message you. Hi. Oh, you did? Oh, I missed it.
Very tiresome.
Oh,
And I was like, I think in the email, I'll for sure make it a class. I'm just
ready late. Okay, I don't know. When did you send it? Yeah. Oh, it's just because I started class. I hadn't seen it yet. Oh, no. Let's see. Yeah, just join a group and go ahead and, let's see, why don't you join this group right here? Yeah.
Does not exist. It does. Or you just time the switch. I remember I helped you out in the over, right?
Oh, yeah, yeah. Yes, we did. Control. And the question.
Big old French tire. Female French. I think it's like, I kind of wanted to look up.
Alright, I just went so.
That's how you say it.
how it
This
is.
is-
I can always hear ask my question.
Organization, user interface.
Word send
If the
question
user
again? Or
decides-
you question?
It's not interface either.
I remember reading OUI in the.
It was in there, but I just don't remember now. Is it?
Organizational unique identifier.
I was gonna guess that next.
This was the frame process.
Oh, you're talking about the
addressing?
What are the two types of? Oh.
Ether and Wi-Fi? I'm gonna try to avoid acronyms. I'll struggle. Okay, what does frame check sequence view?
Frame check sequence?
Yeah, frame check sequence view. What? That's what it's acronym of? FC? Oh, okay. So much acronym.
You got it.
Wait. Organization, like those eyes. Oh wait, no, I know what he's. I know what you're talking about.
What's the IEEE 8 dot?
I don't have cards on my thing.
That's the
With the standards?
yeah. The farmer is the standard.
The IEEE 5th or?
Yeah, the organization.
That's either Office Suite, that's the. What are the two types of? What are the two switch categories?
So it says forwards the frame before it's entirely received as a destination.
It's hard to, I think you might be able to do it.
This one's from Switch.
What's the minimum byte for
Switch speed.
What?
minimum byte?
Fast forward switching sends frame without the entire frame, lower latency. The fragment free switching. Which stores the 64 bytes. Frame before.
What is a MAC address?
binary address. So how many bits are the binary value for the
Where did it collect like the actual Oh, it's like inside a switch. Okay.
15, 16 was the max of something.
But yeah,
The max of something.
It was, I remember reading something,
so you're setting something like
it was like the total amount of that address. Yeah,
That's why I wrote this one down. This is why I wrote this one down because I remember this one from first day too. It's 40. I know the answer. 48. Yeah, 48.
and then the answer was.
Yeah, but I do remember it being good. I think I had a card right now. It's 15 something.
All right, where are we? What do we got?
Well, I just answered what was the, oh god, I forgot the name already. The MAC table? The MAC, the MAC table? Yeah.
What is a MAC address table?
Yeah, I just answered it.
What is it?
I didn't give the full correct one, but from what I remember, it just grabs IP addresses and it just, no? It forms it.
The minute you said IP address, you were wrong.
Okay. MAC address.
MAC address.
And doesn't it combine them all, right? Or no?
Mm-mm. Doesn't combine them all. What was the answer? Whose question was that? Oh,
Did I
okay.
just forget it? I just forgot it.
What answer do you have?
I put it stores the MAC address from incoming frame to the ports.
Right. So it matches up a MAC address to a port number on the switch, like the port on the switch. Because like you brought up, we have two different ports in our world, right? We have ports at the transport layer, which is layer 4, and then we have ports which are also interfaces on our devices. So you have to kind of keep that straight. Okay, what's the next question? Oh.
There's a shared, and based off what I put in here, at least I don't have anything about shared. I know Joe can tell you
Is it the one with the fast food?
You have 2 digits per process, so we have to.
You gave a hint. What was it?
I was just asking if it's the one with the fast food.
Fast forward switching, okay, because the question was, what are the 2 forwarding methods between switches? Okay.
I'm completely lost on this one. No?
Well, Orgil said fast forward switching, so that should give us a little hint here.
That it? Cut through or is it straight through? No, that's the cable.
So fast forward switching is a type of cut through, right? Okay, so that's a type of.
That's the other part of fast
Oh
food.
man.
It's not enough reading or studying going on here.
Yeah, actually. Yeah,
Okay.
yeah, because this, when it, in relation to that, the shared memory, it speeds up and simplifies the communication. This is what it does, specific. So,
What was the question?
it wasn't a question, I was trying to get them to answer.
Shared memory.
Yeah, in the,
So we just went over memory buffering.
yeah.
Buffering. So shared memory is a type of buffering that a switch does.
Joe, who's saying
Yeah.
He didn't bring, he didn't have his cards, but he came with his enormous intellect,
His answers.
ready to,
That's good.
shared memory? We're not going to do everyone in here knows auto MDX.
Do you?
I mean, auto MDX, what is it, guys? Auto MDX.
Checks what how it's plugged in, whether it's
And it's a.
Whoa.
It's a
detects whether it's like send or receive on the Ethernet cable thing. Isn't that what?
What does it do if it's wrong though?
It just changes itself to be correct.
Changes what?
The switch just changes things over,
The
like
interface.
internally. Because it's
So it changes the interface settings, basically. Because it's not doing anything to the actual cable.
It's not physically moving it, but internally it's like, oh, I'm gonna read off of this one instead of that one, you know, and send off that one.
So what are the things that it can sense? What does Auto MDIX sense? What are the other things?
I don't know what you're asking.
Well, Auto MDIX, it will auto-negotiate, right, based on, so if you put in a straight through and it's supposed to be a crossover, it can detect that. Can it detect anything else? Does Auto MDIX do anything else?
Doesn't that have something to do
feel
with
like it does.
IPs? Or what am I thinking of? Right? What's IP addresses? Is that
No,
DHP or whatever?
The yeah, it's DCHP is the one that like
Yeah,
does the
they're-
auto
I'm
assign
going off on
and
a
stuff.
tangent.
Yeah, and we're not really there yet. We're not at IPs yet.
That's the only one that I remember that it does. I feel
Okay.
like the answer is probably does something more based off your answer.
Yeah.
That's what I'm trying to say.
I don't think I remember anything else that it does besides that.
Yeah, we should look and see. Hi, Jocelyn.
Yeah, read-only memory is
What part of an Ethernet frame detects for errors in the frame?
So just the error detection, or is that specifically?
So I have something else right now. I don't know if that specifically is right. I mean, you're in this general area at least.
There's part in the trailer for doing error detection, but I feel like there's also part in the front for doing that as well.
No, well, I was thinking about the trailer part as well, but I don't know if it's called the trailer in this specific case.
Well, within the trailer, you have different sections of the frame. So you have error detection, and you have what else? What's next to error
It's
detection?
the frame stop.
It's the frame stop. And I'm not sure what you're asking for. Are you asking, like, there's some specific types of error detection? Is that what you're looking for?
So mine's got the frame in it.
Okay.
Frame answer in it.
Yeah, so that's a specific type of error detection.
I feel like it starts with an S.
No.
It's got an S.
Oh, it does have an S in it.
Okay.
There's 3 words, and the third word starts with an S. The first word is frame.
Is it like FCS?
Yeah.
I don't remember what the C stands for, but wait, is it frame? Wait, correction?
Come on, bro.
What?
Check.
Oh, frame check.
Yeah, frame check sequence.
Frame check sequence. Okay, so let's tie some of this together. Okay, so let's tie some of this together. There's different types of frame forwarding methods, right? What are the 2 frame forwarding methods?
The cut through and the
cut through is when
The store and forward.
Yes,
Yes,
so
that's
store
what
and
we're-
forward and cut through, okay? So depending upon what type of frame forwarding or switch forwarding you're doing will change or determine the error detection. Because if you're doing store and forward, that means that it's gonna store everything up and then forward it. So that's gonna check everything because it is the type of error detection that it's doing is it's looking at everything. So that error detection, you'll have a CRC, the cyclical redundancy, you have a FCS, so there's a couple different types of frame or error detection depending upon what the method of forwarding is.
The other one is in the front half of the, isn't it?
There's no error detection in the front half. What's in the front half is like, it counts up the bytes. You know, so it'll deliver like, hey, when it gets to the other side, you should have 1,000 bytes, right? So that it, on the other side, it can do, at the trailer side, when it's peeling it open, it can say, oh, I'm supposed to have 1,000 bytes. Do I have 1,000 bytes? 1, 2, 3, 4, 5, 6, 7. Oh, I only have 850 bytes. So, okay.
Makes sense.
Oh, no. No.
Like the destination part is like
What? What was the question?
Well, we were talking about the two parts of the cut through were the frame for the fast forward.
Right.
We were trying to remember like how you remember it. And I was saying the fragment would be the one with the number that way.
Yes.
And then the fast forward is the one where it gets to the destination address. And he was asking how many bits or his destination address. And I don't know. You gotta ask her. 'Cause
Okay.
I'd have to look at the thing.
Let's see if we can figure that. Exactly. It's the same as, yeah. Yeah. Now, so that brings up an interesting thing. The MAC address is 48 bits, right? However, if we want to know what fast forward switching is looking at, there's still the header, right? There's still that frame start. So there's a few in front, and then there's the 48 bits, right? So I don't know the exact number. It might be.
Is that what you were asking? Is it less than the 64 bits?
It's less than 64.
That's what you were asking?
I'll do the last thing. So what?
Yeah, there's not much of a difference. Yeah, for sure. Yeah. Which I guess maybe if you're trading stocks or medical or something, maybe it would make it that much of a difference, you know?
What is
So
the
who knows?
standard for it?
Well, I mean, think about it. All of our stock trading's going over a network, and so companies like that, they want the fastest network they can get. So they reduce the latency on anything and everything they possibly can. But they also need quality, right? They also need quality. So it's a tricky balance when you're doing any type of financial stuff like that. Yeah. And interestingly enough, like a lot of times stock companies that are doing that type of trading, they want a point-to-point connection. They want to get as close to the stock exchange trading, and they want a single point of contact. They don't want it to have to go through the network for packet switching because of the speed. So they do things that don't always seem like they would make sense until you start thinking about it from a speed perspective. So, all right, question.
All right.
It had a page where it was going over like decimals, the hexadecimals, the binaries, and all that. I was like, oh, this is actually something I struggle with. I mean,
And it was, she had the little thing up there.
I only remember that number because
I think she has the answer on there too. There we go. Port-based, and it stores the frames.
Port-based.
I can't figure out.
Yeah, port-based stores the frames in queues.
It's so port-based, and what did you have?
It had stores the frames in queues.
Yeah, so all the frames are getting stored in queues, and I think that queue, I don't know if it's,
Like port queues or something on it?
yeah, I think that just because but maybe even with shared, it's considered like a queue. I'm not sure. I mean, I just think of it like shared memory. It's kind of like a bucket that's in the software of the switch, and they all get put in there, and then that one's not quite as efficient, but because once the traffic congestion clears up, it has to be sorted and sent back to the right exiting port. But port-based, I think, is a little slower, but it's more efficient because it's storing it right there on the port that it's on. So.
price for a less, I'd assume at that point.
And I don't know which one stores more or less. It's hard for me to know. It's possible that port-based stores more.
So if I have port-based and frames stored in queues and then shared memory, I have frames going to memory buffer. Is that good or is that?
That's good, yeah. So shared, it's like a group memory buffer. So read the queue part to me again.
I put frames are stored in queues and then shared memory, I have frames going to the memory.
Okay, so what they're talking about is the queues. That queue would be like a little bucket. It's associated just with that port. It's a little queue, right? So it's lining up, waiting for.
So a queue could be a small memory buffer.
Yeah, it's like waiting its turn. Yeah, yeah, it's waiting for its time. So shared memory, a little bit bigger bucket where all of the ports send their overflow. Port-based they're just staying there, right? They're just staying there. Yeah. Okay, everyone ask one more good question.
Last question. You got any more? You want to Oh, you got a good one?
What's Oh, these are my people.
From this semester or?
Yeah, these are all my people from this semester. Okay, I'll take these two.
I should be looking at their notes.
Are you talking about the last thing being the vendor? Yeah, the first will be
All I have on here is
allow you. No, but I'm just I can't see something. Every word the text would use always like
is
That sounds like
autumn
it's expensive.
Oh yeah, it was like
is MDIX a form of auto negotiation?
Yes,
That's what
they're related. And I was asking them a question about MDIX too, so auto MDIX. And they said that, so auto MDIX, if you have a crossover and you're supposed to have a straight through, the ports will auto negotiate that, right? So that's auto MDIX. What else can it do? What else does it auto negotiate? Yes, yes, and
That's why I was confused, because I knew that MDIX did the ports, but I didn't know if it.
yes, yeah, they're related. They're related. So auto MDIX is the actual protocol, and what it does is auto negotiate, and it can do more than just detect the standards, the T568A, T568B. It can also do speeds. Yes, yes.
Said end on a good one.
I did. Okay, it's 7:11. Let's take a break. Come back at 7:19. Come back at 7:19.
Yeah, but for us, what he did was take two classes and put them into one, so that was like double the work for me. Then he was like,
so you guys sign up for both classes, right?
no, we only started from one. Yeah, I thought that. Really? I don't mean, that was my first time having it, and this is bad impression.
Is it Mr. Loving?
Mark. The Linux, I am Mr.
Man, I gotta watch out.
I mean, I even for Dora, it's really
Which one did you use first?
he's really, no, I mean, both of them. For that specific class, I was struggling. The final exam was so hard, because I don't remember anything, it was so hard.
Yeah, because it's like 18 chapters.
I passed the class.
But I mean, I do not like that better.
Some people would have said I passed it.
So take a break. 7:19.
I meant to ask. I turned in my PowerPoint about not checking my assignments.
When did you turn it in?
I turned into the PowerPoint or makeup late work
I know, but when?
last week maybe before the.
Because I
It was
don't.
around the cable networking,
Really?
cable making class.
Because I checked all of those yesterday, I thought.
Maybe I turned in the wrong spot.
Okay, hold on, let me see. Because I went through, I thought I got through all of them Tuesday or Wednesday. So let me just look and see specifically. Maybe I missed yours somehow. It's not there.
But I was looking at it.
That's what we turned them in.
Yeah, yeah.
So if I don't do So fast, why didn't it?
Lou. It's nothing.
5 pages of just pure like.
Oh, see, I don't, it doesn't notify me when you put it in the comments.
Oh,
I'm sorry.
how did I do? What's the right way to do it?
Just like a regular assignment. You know what I think might have happened? This is my fault. So you just do start assignment and then you upload it like a regular assignment?
Yeah. I uploaded
But
it to PowerPoint.
it's, you put it here in the comments.
I think I just put it in like the late assignment or something like that.
Well, yeah, it's not there. See, it's not, there's nothing there. The student has no submission. Somehow you submitted it through comments and not through the assignment.
Oh, that's weird.
Yeah, so I never saw it. But this might be why. Initially, there was a mistake in the assignment where it wouldn't let you upload, so maybe you weren't able to. I'll look at it, Lou. I'm sorry about that.
Oh, that's fine.
I'll take a look at it, though. But next time, just do it through the assignment.
Okay, that makes sense. Maybe that's why I was confused.
It could have been you, it could have been me, though, because like I said, somebody was trying to submit it, and they're like, it doesn't have a submission. And I'm like, what? I went and looked, and there wasn't a thing that said start assignment, so I fixed it, and you might have already done it before I fixed it.
Okay, yeah.
So I'll take care of it, though. I'll look at it tonight.
Get up in these panels, man. It is gross. Yes. That's horrible. I mean, it's horrible. You want like a hazmat suit and pop those things up there.
Do you think I'm driving early in the morning and my car gets turned on? What's happening? So then I had someone pass me cable. Didn't work. Like, okay, so the battery. Like, I don't know what it is. I kept trying. But I got told that because it's such a $200 car. And then, so 2006 Ford Model 3. Shit box. Like my shit box. So then I got it towed. I called over a mechanic.
All right, so let's get started. I've just published a VLSM activity. Okay, so we're going to do a VLSM Canvas assignment. All right. So this is VLSM 1F. So this is the topology, more or less. So let's just look at this and talk about it for a second, okay? As an administrator, you've been asked to set up an addressing scheme for this new office. There's a sales department, right? Oh, this is a finance and a customer service. This doesn't match. Ay, ay, ay. The starting address is 202.168.0.0/23. And notice here what it's asking for. It's asking for the network address and the broadcast address. So we're just figuring out like the network, the very first address, and then the broadcast. And then from there, we can figure out everything in between, right? And then we're going to do some things with the topology. I'm going to go make those words match what the actual thing says. Okay, if you need a helper table, we've got some in the back. Edit. Let's see, so we have a warehouse. Yeah, I like the tables. There's less mistakes. It should be open. Yeah, it should be. Refresh your screen. And then we're going to work a little bit more with the topology once you're all done with the actual addressing. So let's add a couple things. So 123, what subnet mask will take care of that? I'm sorry, 123, which subnet mask will take care of that? A 25, so let's see, 255, 255, 255. What is it? 128, which is a /25. You have to keep practicing all of it, right? Okay. What will take care of the delivery department for 60? A what? A 26? Okay, and what's the subnet mask? How do I write that in decimal? $192, which is a /26. And then Matt, how about 5? For 5, a / Orgil, 5. What subnet mask will take care of 5 hosts? A 29. And how many does that give us? 8 total. How many usable? 6. And what's the subnet mask in decimal? $248. Okay. Did everybody get that far? I see a lot of .9s. Is there a mistake in the answer key? Or is it a typo?
I mistyped. I forgot the /notation.
Oh, okay, okay.
It's one of the things I
It should be-
run into whenever I'm doing these is I'll forget to do like the /notation on the last one. It always costs me like 1 or 2.
Yes. Yeah, it's supposed to be a 10. I don't know why it's only 1 point. I'll fix that. Okay.
I did notice it's like 0.7.
Yeah, it's supposed to be 10. It's just typo. There's typos. Okay. What would the first network address be for our warehouse? Daniel.
I didn't hear what you asked. What was the question?
The network address for the warehouse.
I have 202.168.0.0/25.
25. And then what'd you come up with for, what'd you come up with for a broadcast?
I have 202.168.0.127/25.
Okay, that looks good. And then let's see, Marcus, what do you have for the next network, for the delivery network?
202.168.0.128/26.
/26. And how about for the broadcast?
202.168.0.191/26.
Okay. And let's see, Joey, do you have the sales network? Point of sale. Okay, what have you got?
202.168.0.192/199.
Okay, and how about for the broadcast? 29. Let's see. So a 29 increments by 8, and that's, yes, nicely done. Ozzy, do you have the WAN done? Okay.
So it's 202.168.0.200/30.
30. And the broadcast?
202.168.0.203/30.
Yes. And Lou?
On the fourth octet, I got 204/30.
Oh, and the fourth, okay, I got it. 204/30, and the broadcast?
Fourth octet, 207/30.
168.0.207/30. Okay, so let's look at this, right? And remember, if we think of it like it's just counting, right, between 1 and 255, we always start with the address that they gave us, but it gets a new subnet mask, okay? And then we're flipping on just the host bits, right? We're flipping on just the host bits. That's how we get the broadcast. Now, are these addresses usable addresses? Can I use them to assign to a host? I can't, right? They're not usable. They're not usable. One's reserved for the network, one's for the broadcast. And then what comes after 127? 128. So we can see that's the network, right? And then from here, between 128 and 191, that's the broadcast. Everything in between there can be used to assign to the host. So 129, 130, 131, 132, 33, 34, right? All the way up to 90, 190. And then since we know that this is the broadcast, the very last address of this network, the next address would be the network address of the following one, okay? So we've got that, and because we know the network address and the broadcast, we know everything in between. The next thing we're going to do is we're going to work on the topology and just see how all of these addresses would apply, how we would apply them, okay? So I'm going to pull the addresses over here, and I'm going to pull the topology up. Where is my topology? And I'm going to put that over here. So you should all have this topology. I do. Did I not get enough out?
Oh, wait, never mind. I was passing them down, sorry.
Well, actually, I don't think I saw it.
Okay. So how many networks do we have? How many networks do we have? How many total networks? Right, we just figured it out. We have 5 networks, right? What kind of networks do we have up here? We actually don't have a wireless network showing anyway. Yeah. What kind of networks do we have up there? What are they? So we have some LANs. How many LANs are there? Yep. We have 3 LANs. So since we have 3 LANs, how many default gateways are there? 3, exactly. Okay, so we have 3 LANs. What else? 2 WANs. 2 WANs. So we have 2 WANs, right? Okay. And can somebody come up here and draw a circle around the WAN networks? Okay, so somebody come and draw a circle around the WAN networks. The 2 WAN networks. You want to give it a go, Lou? We do. Yeah. Because we want to start breaking down what these topologies look like so we can also imagine them out in the field. Well, there's 2 of them. Almost. So let's see. So step a little over there so we can talk it through and everyone can see. So you're on the right track, but you see how you encompass this whole network, like this whole router, and then you've also included that. Oh, okay. But we want to just get WAN 1 and only what would be part of WAN 1. This interface is actually part of a LAN. So when you're figuring out where the WANs are, you have to be really descriptive about what interfaces are part of your WAN. So give it another go. Well, you want to include the whole thing and the connection points. So like that, because did you mean like just this and just this, or did you mean like this?
Yeah, the whole
Yeah, yeah. And include those two interfaces. Perfect. Perfect. And then do the other one too. So when you're doing your topologies and you're thinking about what's included in your network, you want to make sure you get the actual correct interfaces and not the other interfaces, okay? And then, let's see, how about, can I have somebody come up and circle the LANs? The LANs. Here, let's try the green. Oh, this might not work. I don't think that's a... Okay, so circle the LANs. And again, think about the interfaces that are part of the LAN and the devices. Yeah, it's all those devices. Yeah. Perfect. All three. Go ahead and do all three. It's tricky being a teacher with the light up there. It is. Perfect. Okay, nicely done. Nicely done. Okay, so on yours, I want you to circle where your LANs and WANs are, being really careful to include the interfaces that belong, okay? Everybody got that? Man, I keep losing the mouse. Okay. The next thing that we want to do is we want to apply the addressing. Okay, so we want to apply the addressing. So start with the network address. Okay, start with the network address. We've already kind of got these labeled. Okay, notice this one's already labeled WAN 1, right? And this one's labeled WAN 2. So you would always want to label your WANs and your LANs. This one's labeled with warehouse, this one's labeled with delivery, and this one's labeled with the point of sale. The next thing you want to add is your network addresses. So associate the network address with the network that it represents. Okay, so this point of sale, somebody give me that network address. What is that network address? 202.168. Was that for point of sales? I thought that was a smaller one.
You're right.
Point of sale.
No, it's 0.192.
Okay, 0.192/29. Okay, so we want to label this network. So I have it named, and I have the network labeled. Okay. And then let's see. Somebody give me the delivery network. Matt, you got it? For delivery. Oh. Oh. Guillermo, do you have it for delivery? 128/26. And then Gabby, how about the warehouse? 25. Okay. In almost any networking job, data center job, cyber job, you're going to need to know how to draw topologies, identify the networks on the topologies, label the topologies. you'll always have a topology. Things live and die by a topology and documentation, okay? And it's not going to be uncommon that you might have to explain things to a customer. And if you just say, well, there's 3 WANs and the network is this and that, and then there's some WANs, like that's like, whoa, what? Like that doesn't compute for a customer. So a lot of times they're going to need a visual representation of what it is you're wanting to explain to them. The same can be true for a manager or a supervisor, right? You might be reporting to someone that doesn't have a deep networking background, right? That happens all the time. And so you're going to have to be able to explain it to them in terms that they can understand. Okay, so we're missing the WAN. So somebody give me the address for WAN 1. 30, okay. And then WAN 2, I think that was 204, right? Okay, so get your topology all labeled. What could we label next that would be really helpful? Yeah, absolutely. It would be really helpful to label the default gateway, right? So let's go ahead. What I want you to do for that is I want you to, somehow highlight that, your default gateway, because isn't that going to be the interface on the router that faces your LAN? Okay, so I want you on your paper to find a way, either with a little circle or color or something. I want you to highlight or circle your default gateway. Draw attention to it. Okay, somehow draw attention to it. So on this one, it's right here. Okay. So right about right here. Here and here. Okay.
I label them with like DG, so you know that.
Yeah, that's good too. DG, I like that.
I'm pretty sure I'll know. It'll be DG, but it's always a chance.
Got it.
Yeah, yeah.
Perfect. Okay. All right, now we're going to add the address, okay? Because it's going to be, we want to get that address on there. Now there's a couple of different ways. When I have room, I write out the whole address. If we follow the normal rule of thumb, and let's say I'm looking at this point of sales network and I know what my network address is, what address would I put right here on this interface? Yeah, the very first one. So I'm going to do 202.168.0.193/29. Okay, I'm going to write out the whole thing. If you think that you'll know by just putting a .193, as long as you know that that belongs to this network, then I'm okay with that. I'm going to write it all out because I want to be able to just see it and not have any questions. The more I can do to not make mistakes when I'm working on a customer's network, the better. And then do that for the other 2 default gateways as well. Okay. Get the IP address in there. Oh, do you need? Oh, you got one for him, Daniel? Okay. Okay, so Lou, what's this default gateway right here for my delivery network?
That'll be 129/26.
Okay. And let's see, Orgil, how about over here on the warehouse? What would my default gateway be? dot 1. Okay. Everybody got that? Okay. Now, let's say that I was going to set up a switch virtual interface, an SVI. Why would I set up an SVI, first of all, and what device would I be putting that on? Caesar?
The SVI is that's the virtual like connection that you can use to connect into the router, right?
Right. What is it, Daniel? You have half of it right.
Switch virtual interface, that's where it's virtual interface, where you can connect to the switch.
To the switch. That's what you missed. You said router. So it's a switch virtual interface, right? That's what we did in the lab with the VTY line. And so that would be like an interface what? Nope, not the console. Interface VLAN 1. That's how you set up the SVI, is you have to assign it an address. And then remember you use those line VTY04 commands. What does the line VTY give us access to? It gives us access to the device in what way? It's a virtual, exactly, virtually. And is it in band or out of band? It's in band, so it's different than the console. Okay, yeah, yeah.
I know we've been putting 04, but we did have one that had
015.
015 or something.
Yeah.
So is it a good habit to always do the question mark, find out how many lines you have?
It is, or you can do the version.
Okay.
The rule of thumb, it's not always, so most routers have 5 VTYs, 04, 0, 1, 2, 3, 4. Most switches have 16, 0 through 15. You can do a show version or the question mark, I think will tell you. So it is a good idea, especially like if you want to lock down those extra ones. Yeah. Okay.
Well, I'm saying, yeah, so if there's 15 on there, you do 04.
Yes, you leave the others, yeah, that somebody potentially could gain access. Yep. Okay, so what I want to do is I want to use the last usable address for our interface VLAN 1 or our VTY access on each switch. So we're going to apply the last usable address onto the switch. For delivery, what would the last usable address be for the delivery network? $199. Yeah, it would be $199. No, not $199. That's the broadcast. 198, right? 198. So here, let's go look. Let's go look. Hold on. Yeah, I gotta look. Okay, wait a second. Delivery. 190. So the last usable address for delivery would be 190. We got to refer back to our addressing. Okay. So what I'm going to do is I'm going to put a .190 here /29. Oh, dang it. Yeah, I'm looking at one and talking about the other. Okay, hold on. .190 /26, right? And that would be on the interface VLAN 1 if I needed it. So it's the .190 /26, and that's what I would apply to the switch. Okay, now let's do point of sales. What is the last usable address for this network? What's the last usable address for our point of sales? So if I go look at my point of sales, the broadcast is 199, so what's the last usable? 198. So I would apply the .198 /29. And if I were setting it up, that would go on the interface VLAN 1. So add that. Right, we're just tracking everything. So on your labs, what I want you to do is I want you to start looking at your topologies on your labs and adding the addressing. Start visualizing what this network looks like. How are these IP addresses applied? Because after module 9, we're going to start moving into the network layer, which is IP. And then what do we have left? The warehouse. Okay, so the warehouse, what would the address be if I set up interface VLAN 1? .126/25. Okay. Everybody got that? Okay. WANs. Do WANs have default gateways? They don't. Remember, the default gateway is just a term that describes this interface on the LAN. When we're talking about WANs, they're just regular interfaces, and we don't really give them a special name. They're just regular interfaces. And so in this scenario, I want to assign an address to each interface. Remember, when we did that lab with the router, these interfaces don't work on a router until you've added the IP address to them, and what else do you have to do after that to get them to work? No shut. You have to do the no shut command. But they won't do anything without an IP address. Even if you do a no shut, it'll bring the interface up, but it still can't move packets because that's a layer 3 function. All right, I want to give an address to this interface and this interface so that they can move packets. What address could I apply to this interface right here? 201.201/30, and how about right here? .202/30. Okay. All right, let's move over to our other WAN. And I've got an interface right here. What IP address could I assign to it? 205/30. And then how about this one down here? 206/30. Okay. So you can kind of get a visual idea of how the IPs map out. The last thing I want you to do is go ahead and assign an IP address to each of these PCs. And how do you know what IP address that those two PCs could use? What's that? Yeah, you can look at the network, and as long as they haven't been assigned to another device, you can assign it. So like, for example, could PC3 have 202.168.0.15? Yeah, right? PC4.25. So just, I want you to write out an IP address. Again, it doesn't matter to me as long as it's within the range. Just make sure it's in the range. Do the same for your delivery network. Put some addresses that are in the range. Make sure you're inside your range and that it's not an address that's already been used.
We're just doing PCs, or we're giving the printer one too?
Yeah, I'm giving the printer one too. Yep. Give the printer one, and then over here on your point of sales, give these servers each an address. from within the range, okay, from within the range. You don't have to use the ones I've used, just make sure it's within the range and that you haven't used it already. Oh, I have one too many. Let's see, we have 93, 94, 95, 96, 97, 98. I gotta kill that one. See, I have too many devices for that network. Everybody see why? It's not enough IP addresses. Because I assigned one to the VLAN. See, look. I can. Yeah, I probably need the server more than the VLAN. Absolutely. So, yeah, you're right, right? So again, you see how important it is we think it through? Okay, everybody got their addressing? Might have to take that VLAN address off of your switch. It's a rookie mistake.
I know it's missing.
As long as you can read
I
it.
can read it.
Yeah.
What if any other computer on the network wanted to use the printer?
They'd
They
have
would
to
use
call
an
that
IP.
PC to do it.
Yeah, you'd have to have a printer server on the server.
Yeah. I mean, yeah.
All right. Got it? Got it, got it, got it. Okay. All right, let's take a break. All right, let's take a break. It's 8:04. Come back at 8:10. Okay, come back at 8:10.
I bet they need a lot of, they print off a lot. Yeah, that's the point. When you need to print there, if you need to print the CNT, because in theory, you print it. Why would you do that? But that's, whatever attaching all paper up. Yeah, so if you put references.
So this is, they've got the sale, they print out the mailing label, and then it goes to the delivery department.
They don't have a printer at delivery. They could put one in. Actually, yeah, they do.
I think you're overthinking this.
You don't even need to. You just go up to the machine, plug in the cable for that. I'll over engineer it. Just so you can have an open DTY all the time. You don't have to open it up when you need it. Just yeah, I'm going to town for a week. Without a printer. I don't remember what class it was in. It was they're talking about how like an actual story of some university. Because servers they keep emailing him. So he comes back from his vacation. He goes and he networking conference, and like I had to come in on my vacation. I'd expect that. That is something. Have you seen the new Intel Mac? It is massive. Like I heard it was big, but then I drove past it. I don't know. I saw it when I was going from 32. So it's down there. It is really big, and I'm like, wow. I know Qualcomm's building theirs up north, but still like within the city. I feel like. I have family that that's the only reason I go to. Yeah, my grandparents live there. Fair enough. My great grandparents are still out there, and I'm like, I'm 20. I can just have a children child. You can have great grandparents at any point. Like, there's a point where you're just old enough to not, just not. Yeah. I know the person who's doing the networking at Intel Factory too. That one would think. Yeah. Like he's high enough where he doesn't have to deal with like the physical leg of the cables, or just have to deal with ABS. That's a dream right there. Yes. No physical leg of cables for days. Did you? Oh, for the one assignment. Didn't.
Talked to you last week, there was a point where you said something about having an advisor or something. And I said, I just got an counseling appointment. I was going to ask you, did you have a name of advisor? I should ask for it. You were recommending one or something?
I use Julie a lot.
Okay, so ask her.
Yambor. Yeah. Yeah, she's the best, right?
Okay.
I've had her all 2.5 years.
Julie Yambor.
Yambor. Okay, I'll write it down.
Yeah. And she and I, like, if you want to have a conference with the three of us, just tell her, hey, can we add Andrea onto this? And we do that all the time.
Okay.
Yeah.
Yeah, that would be great. I was going to say, if I can't get a hold of her, would you be willing to
Yeah.
help me out with
Of course.
figuring out what my-
Yeah, of course. Yeah.
Get it plastered on the wall.
Okay, I published a Frogger. So get that Frogger done. And Julie Yambor. Yambor. There's a Frogger in there. And can you go into the virtual machine too? We're going to be working on a packet tracer, so make sure you're in the virtual machine if you're not already. Yeah, do the Frogger and get into the virtual machine. Whatever. Oh, do the Frogger outside of the virtual machine because Frogger doesn't like the virtual machine. It's like. It doesn't, yeah, it's like super slow. So do the Frogger first. Or just at least do it outside of the. strange. It's very strange.
The packet tracer, is it the one
It's not published.
oh,
You can't see it yet.
alright, no worries. I'm looking at a one from a different day, okay?
I've seen mistakes on this one that I fixed when I was in my office, and I don't know why we're seeing this old one. Yeah, this is correct. It's very strange. Is everybody done with the Frogger? Because you mastered it? Give me just a sec. I'm trying to see why this is an old assign, why this isn't updated. Okay. Okay, so I'm going to publish this, and you're going to download the packet tracer and the Word doc. You have to be inside the VM. Don't work ahead. Don't work ahead. It'll mess up the packet tracer with what I'm trying to show you. Okay, so it's in week 7. It's got today's due date on it. It's the packet tracer demo module 7.9 Mac and ARP table. That's it. When you have the packet tracer open, can you pop your hand up? Yeah, it might ask you to log in. Chase, can you go put this packet tracer into a PKA? And I want these ports off. turned off. It doesn't have to have a grading mechanism.
The labels and the port
The labels are okay, but I want the ports off.
labels.
Yeah, just I want the port labels off. Like the name of the device is okay, and but not the port labels. Okay, everybody got it open? Okay, so click on options. You'll need to edit it, yeah. I think so. So everyone go into options, preferences. And then if your always show port labels is on, can you unclick that? So if your port, if you go into options, preferences, and then if this one always show port labels, if it has a check mark in it, uncheck it. It just makes it so messy. And then also it kind of defeats what we're trying to do in here. And then you can kind of move these around so that you can see things a little clearer. Okay. So we're just going to kind of poke around today. We're going to look at some ARP tables. We're going to look at some MAC address tables. We're going to see the MAC address table fill up. Because next week on Tuesday, I think Tuesday, maybe Thursday, I'll look at the schedule. We're going to do a lab. And so I want you to look and see what you'll be looking for in the lab by doing a packet tracer first. And we already took a first glance at it on Tuesday's lab, when it had you look for the MAC addresses for the interfaces and the MAC addresses of your PC. So that was like our very first glance at it. Today we're going to look at it again in the packet tracer, and then next week you'll do the lab, okay? You'll do the lab. So hopefully between this packet tracer, the packet tracers that you do for assignments, and then the lab, it'll start to make sense for a lot of what we're doing. Okay, so everybody got this up and then turned off the port labels? Perfect. All right. The first thing, let's just like click inside of this PC0 and go to the desktop and the command prompt. And let's do a look at the ARP table. Now the way we look at the ARP table is you type ARP-A. And what we see here is that there are no ARP entries because as of yet, our network hasn't started talking. It hasn't started talking. I thought of something I was going to say and it just left my brain. What was I going to say? I don't remember. Hopefully it'll come back to me. It's the second time it's left my brain. I thought of it earlier, and then I forgot it, and it came into my brain just the second. Okay. And here what we've done is I've already let us see the IP address and let us see the MAC address so that it's nice and easy just to verify stuff when we're doing the different pings, okay? And then let's go down here. I know what I just thought of. Okay, thank you, brain. All right. Earlier, we were talking about how ARP lives between layer 3 and layer 2, right? Because it matches up what kind of an address to what kind of an address? IP to MAC. IP to MAC. Oh my God. Oh my God, what is happening? This is the third time. Oh my gosh, okay. Router, ARP table. Okay, here, I got it. I have to say it right now. The router has ARP tables and the computers have ARP tables. Okay? I want you to think about when we were talking about cabling, okay? And what kind of a cable do we use to connect a router to a computer? crossover, because even though they look very different, they have similar brains. Okay, well, the computers and routers more or less live at layer 3. Even though our computers are connected, you know, at a layer 2 with Ethernet, so are routers with Ethernet, but the way their brains are, they're functioning, they're kind of living at layer 3. That's why we can see ARP tables on our PCs, and we can see ARP tables on our routers. We can't see an ARP table on our switches, okay? And for the most part, we really don't see MAC address tables on our routers, because the routers are living at layer 3 and switches are living at layer 2. MAC addresses are layer 2, IP addresses are layer 3, okay? So that's why we would see ARP tables on our devices, on our end devices, and we will not see ARP tables on our switches. That's what I was trying to think of. Okay, let's see here. So let's go, we looked at that. Now on the switch, let's go in here and what show command can I use to look at the MAC address table? I went into switch 1. What show command can I use to look at the MAC address table? Yeah, so show MAC dash address, then what? Does that work? Okay. What's the full command if we needed to do the full command?
Isn't it the IP big one?
Nope. Show MAC address table, yes. Okay. Now, sometimes, depending upon the operating system that you are using, you might have to use show MAC address table dynamic. Okay? Now, if we look at this, what we're seeing here is we see that VLAN 1 has this MAC address. It was learned dynamically, and it was learned off of port G02. It was learned off of port G02. Okay, so let's see here. If I look at G02, that's probably this port right here, because I don't think this is there. What can I do to go maybe find this MAC address? Where might I find this MAC address? So let's think about it. This MAC address was learned from port G02. And when does the switch learn about a MAC address? Incoming, right? So if we look here, right, we can see that there's only a few ways that a frame can come into this switch, right? And we can see here that D3B7, that would be coming from PC0. 6B86 would be coming from PC1. So chances are this MAC address is coming from this switch, because that's the only way it can learn is on the incoming, right? It can learn on the incoming. So let's just keep that in mind, right? That it's going to learn on the incoming. And let's see, how about if we go over here to switch 2, and let's do the same thing. Let's do a show MAC address table. And again, now here we have 2 entries, right? Why? And we haven't generated any conversations yet ourselves, right? We haven't done a ping, we haven't sent an email, we haven't accessed a server, we haven't done any of that, right? Where might these MAC addresses be coming from? Yeah, that's coming from the switch and or the router, right? Because I can see here, like none of these have talked as far as we know. And there's a G02 and a G01. They were learned dynamically. So chances are one of them came into this port and one of them came into that port. What does that tell you about intermediary devices on your network? Looking at the MAC address table.
They're always talking to each other.
Yeah, they're always talking to each other. Like as soon as you kind of start plugging them in, they will start sharing information. And as you've done labs, have you noticed that when you plug in a cable, sometimes it'll be a yellow light and then it'll go green, right? And that's because it's already starting to communicate. They're already starting to share information. And they do that because when they actually do start getting and receiving traffic, having this information in the MAC address table already allows the traffic to be moved faster. It's more efficient because there's already some information filled in the MAC address table. Make sense? Okay, let's go look at R1. Now this is a router. Are we going to see anything on a MAC address table? So let's take a look. Nothing, right? Now, instead of a MAC address, now sometimes a router can keep track of MAC addresses. There are occasions when it will, but not for what we're doing right now. What might I look at where I might be able to get some information? Yeah, let's look at ARP. Now, are we going to see anything in there? Show ARP. We've got something, even though we haven't been talking, there's some information there. Okay. Now, ARP keeps track of what things? Like, what does it match up? What's it resolving? What's it matching up to what? Yeah, an IP address to the MAC address. Now, we are also seeing some interfaces here, but it's a little bit different because it's not so much how it was learned. So, Internet protocol, so we've got 10.10.0.1, and it's this hardware address. And that, let's look on our topology and see where that one is. So that's this over here. That's this one over here. Okay, that's this over there. And then, let's see, 172.21.01. What is that? What are they talking about? 172.21.0.1. The default gateway. Yeah, it's the default gateway for this local area network. Okay. Let's go look at this interface on the router. Let's look at interface G01. So show interface G01. And then I want you to find the MAC address. So on here, what are we calling the MAC address on this output, Joey? Yeah, it's the burned in address, and we can also see hardware, right? So here it is. Now, this is where things are different. This interface has this MAC address or this hardware address, and it's telling us that on G01, we've got this MAC address, and it's associated with that IP address. When we look at the MAC address tables, the port number is telling us what port learned about the MAC address. So it's different. It's different. It's not the same type of an output. What is the difference between a hardware address and a burned-in address? Are they? They're different. There's something that's,
Address might be on the ROM.
yes, the burned in address is on the ROM. What's important about that? Why is it important that it's on the ROM? Exactly. It's less likely to be spoofed. Now, the truth is, there is ways to do that. It's very difficult. And in years past, literally, they would carve the address into like the hard drive. It was carved in. That's why it's a burned in address. Now it's in ROM. Okay? And then, so what happens is during the boot up process, okay, the burned in address is in the ROM. You do the boot up process. It goes and it looks, it finds the MAC address or the burned in address, and then it takes that and it puts it in the RAM so that it's quicker and it can access it much faster. Okay, now that one is easier to spoof. As a cybersecurity professional, a security professional, if you see a device that has 2 different MAC addresses, your spidey senses should go up really quick, right? Because if your burned in address and your hardware address are different, you've got a serious problem unless you purposely did that yourself as a network administrator or a hardware administrator. Okay, let's see. All right. Looking at this, just looking at the topology, now we turned off the port labels because I didn't want you to see them, okay? Because there's a way to find all the information that you need by using show commands and understanding and knowing your topology. All right, so let's see if we can figure out like what port PC0 is attached to. At this point, we haven't done any pings, right? And if I go back into switch 1, let's do one more show MAC address table and just see if it's learned about anything else. And it hasn't. It hasn't, okay? All right. I want you to see if you can go in. I want you to find this MAC address. So on switch 1, I want you to find 0001C7A0. I want you to tell me where, like, how did switch 1 learn about this? It learned it on G02. Where's it coming from? So we know it's got to be coming from over here somewhere, right? So, but where? So do some poking around, do some show commands and find it. Yes. Switch 1 has learned about this MAC address off of its port G02. So I want you to tell me, where did this MAC address come from? Where is it living? Where's its home? Use some show commands to tell me where that MAC address is. Chase, there was another packet tracer that we did in 150 last night that's supposed to be broken. It's a troubleshooter, but the part that's supposed to be broken isn't broken, and it used to be broken. It's like somebody fixed it and then saved it and then reloaded it. Can you find that one, please? It's from last night's class, Wednesday night's 150 class. It's the one that's a switch port security. It's a 3-parter, because I want to get that broken, and then I want to delete that one. Okay, when you find it, let me know. Somebody raise your hand. Let me know. Marcus, did you find it already? No. No? Oh. Are you looking? Yeah. Keep looking. Don't give up. My guess is the broken one is someplace, but somehow it got loaded. Week 7. In-class activities, Wednesday. Actually, I think I assigned it on Monday. Yeah, I assigned it on Monday. That's the demo, and then there's a troubleshooter right after. It's this one.
Okay.
The first, when you pull it up, let me know. Who's got it? Are you looking at what are you looking at? But what are you looking at? What show command are you using? Well, that's not going to show you, right? Because you're trying to find that MAC address. And we already know that it's not in the, so what interface or device does that MAC address match up to? So you might have to look at the interfaces. You got to look at the interfaces. You know which one this is? So this is supposed to be plugged into this is plugged into F02.
Oh, it's this
And it's supposed to be plugged into G02. Like the F02 is the right one, but it's actually supposed to be in G02, the broken one. Or because this is supposed to go into G02, but plugging that into G02 is what broke it, is what instigated security. And that's what they're supposed to figure out. It's cabling. Who's got it? So if we map it out, G02 is right here, and it's learned about that MAC address, so it had to have come from switch 2, probably. Did you find it? Yeah, so we're looking at the MAC address table for switch 1, okay? And remember, the switches learn about a MAC address when a frame comes into it. So because we see this MAC address on switch 1, we know that it had to come in to it because it learns a MAC address when it comes in. Well, we haven't generated traffic from either PC, so it's not coming from a PC. These are communicating. So something on switch 2, right? The frame is coming in, and that's when it's learning. So you got to find that MAC address. What interface on switch 2 has this MAC address? Yes. Did you find it?
The interface, show interface,
Yeah.
and it shows gigabit Ethernet 2.
Right.
0.1.
Mm-hmm.
3.8.
Yeah.
3.8 LA. Or
So that's that one, right? 381A? Yes.
So I think I'm
Yeah, did you look, which interface are you looking at?
interface, I just pulled interface
Yes.
go to.
Yeah. Okay. So let's look at, go to switch 2. Okay, go to switch 2 and do a show interface G02. Okay. And there it is. 381A, 381A. Okay, so switch 1 learned about the interface G02 when it was, because they're talking back and forth to make a connection. They're talking back and forth to make a connection. All right, so now that's in there. Now let's generate some traffic, okay? So from PC0, ping PC1. Okay, ping PC1. Okay, and then just ping it and then stop for a sec once you get your ping. Now let's look at the ARP entry. Okay, so on PC1, let's go look at ARP. Because before, remember, there was no ARP entries. Now what do we see in our ARP for PC1? PC0, sorry. So when PC0 pinged PC1, the pings went through, and ARP, notice what it did. It matched up PC1's IP address to the MAC address, 6B86. Got that? Okay, now let's look at the MAC address table. Okay, let's look at the MAC address table on switch 1. So go to switch 1. Okay. What port is PC0 attached to? What port is PC0 attached to? Are you sure? Okay. A switch learns when the frame comes into it. So we did a ping, right? So we did ping, 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 ping. A frame came into the MAC, it came into the switch. It looked at the MAC address table, and it's like, oh, I don't have anything recorded for this PC. So it recorded the port number that it learned about, F024, and then it recorded the MAC address that was associated with that device. We can now tell that PC0 is attached to F024. Okay, now, again, let's think about it. So it's pinging, ping, 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 ping. It did an ARP request. Now, PC1 receives the frame. And now what does it have to do? It has to reply. So now what it's going to go, okay, echo reply, 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 reply. The frame is going to go into a port. It goes into F01, and it records the MAC address of PC1, 6B86. We got that so far? Okay. Now let's see here. Let's look at switch 2. Do a show MAC address table on switch 2. Is there going to be anything else on switch 2? What do you predict? Will there be something on switch 2? More than just the one MAC address that we saw? So let's see. When we looked earlier, there were 2 MAC addresses, and now there's 3. But why are there 3 when we didn't ping anything over there? Why are there 3? Why?
Because it didn't know the proper MAC, what MAC address is on. It didn't know where the computer's MAC address was, like what port it was connected to, so it sent it out to all of them.
Yes, and what's that called? It's flooding, but more specifically, what kind of a message did it send? A broadcast message. Yes, it sent a broadcast message, right? So the ping, right, that the ARP request, it actually goes like this because it didn't know where it was. It didn't know where it was. Okay, so which one is the new one? Which one is the new one? D3B7. And that's this one, right? Okay, so let's just see what it did. The ping came down, right? The ping came down. It didn't know where it was going yet, so it flooded out all the ports, right? So as it comes into this port, G02, now switch 2 has learned about PC0, and it learned about it on G02. It learned about it on G02, so it records it. So it records that, hey, that PC, if I need to get access to it or someone else sends a message to it, I know exactly how to do it. I got to get it to G02. So let's go to PC2 and ping PC0. Will it have to flood it? It will not have to do a broadcast flood because look, it knows exactly where to go. It knows where to go because it's already got it in the MAC address table. So from PC2, ping PC0. Look at the ARP table. Oh, it's already cleared itself out. Let's look at the MAC address table on switch 1. What will switch 1 have just learned about? Exactly. Switch 1 should have learned about PC2 on what port? G0, is it G02 right there? I don't even remember now. Because it's going to go like this. It's going to come in. This port is going to learn about that MAC address table, that MAC address. So we're going to see 7838 in switch 1's MAC address table now. So let's see, show, and just do an up arrow. There's 7838. What are you noticing too? What's happening to these MAC addresses after a little bit of time? Yeah, they're aging out. They're aging out, right? Let's clear the MAC address table. So we're going to type clear MAC address table and then do a show MAC address table. And now they're all gone. Now you got to be really, really fast. So I did a clear MAC address table and notice there's nothing in there. Does yours have nothing? Do an up arrow and check it again. Is there going to be something in there? Yeah. Why? Right. Right. So I was able to do it fast enough, but they're already like, wait a minute, right? Okay. The next thing we want to test is, let's clear our switch 2's MAC address table. Oh, look, it's already there. And let's go to the router. Let's look at let's do an ARP table here. Show ARP. A couple things in there. Okay. This is what we're going to do next. We're going to ping the PC0 on this other network. Right? So from anywhere from PC0 to PC0, what are we going to see in the MAC address table when I ping this? What am I going to see? What will I see? I'm going to see switch 2's MAC address. So from PC0, if I ping, first of all, what's going to go into the MAC address table? PC0, it's going to get this one, right? It's going to go across, and we're going to ping up here. Okay, and so what else am I going to see? Is it really going to ping over there? Frames work on what layer? The data link layer, okay. 2. So the MAC address for this one on 10.10.0.2 ends in ACBD. Are we going to see that? ping it and find out. So ping from the LAN over to this remote network. And what are you going to see in the ARP table? Look at the ARP table too. Okay. So when you ping from here to here, did you get a request timeout? Okay, why? Why? It's not the broadcast. I mean, it is a broadcast, but what is that? Why is it a request timeout? Why didn't we get a successful ping on the first time? It doesn't know the MAC, right? So what's it doing?
So it's sending to the router a request.
What kind of a request?
It's the ARP request.
The ARP request, exactly right. It's sending an ARP request. Okay, so do an ARP A. Why don't I see that 10.10.0.2 when I did an ARP request? It is, yeah. It's on a separate network, so keep going with that. It's on a remote network. Exactly. It's going to be the one from the router. And look right here, 172.21.0, the default gateway. This is why the default gateway is so important. An ARP request lives between layer 2 and 3. It actually can't cross over a router. It stops at the default gateway. And so now the switch knows that if it gets a packet or a frame destined to a remote network, it sends it where? To the default gateway. It has to send it to the default gateway. Let's go look at the MAC address table. And right there, there's the default gateway. See? 1502, 1502. Okay, does that make a little sense for how the MAC address table is working with the ARP table? Yes, Andrea. Okay. You do not have to turn anything in on the Word document. The questions are in Canvas. Okay, the questions that I want you to answer are in Canvas. Yes. Yeah. Did you find it?
I didn't find the issue with that.
Did you fix it? Did you fix it and make it broken?
It was already broken.
How is it already broken?
Did you show me the right one, or?
Yeah.
Yeah.
So this, what's the server? The server should be plugged into G02.
No. The PCs should be plugged into, the management PCs should be plugged into G02.
I know, but then that works. That's what they're supposed to figure out.
Yeah.
But the server is plugged into F02.
Is that?
Yes, and that's the right place for it to be plugged in.
Okay.
Go look at the descriptions.
Yeah,
It's
because the server's supposed to be plugged into F01.
oh, well, I want it plugged into G02. I want it plugged into the management port,
Okay.
to the manager's station. That's where it's supposed to be plugged in. Let me make an announcement real quick as you're finishing this up. So on the other side of your topology is another topology. Okay, this topology lines up with VLSM1E. This was due on the 23rd. Most all of you completed it. Some of you didn't. And this is the topology for VLSM1E. Okay, so I want you to do to this one what you did to this one. Circle the networks, label the addresses. Again, VLSM1E was due on the 23rd. Almost all of you have finished it. If you didn't finish it, go in and do it. And then you're going to turn this in on Tuesday, your topology with everything circled. Okay? And then Module 9 is what we're doing next week. Module 9 is really short, but when you're doing it, think about how it relates to the MAC address table, how it relates to Module 7, okay?